Welcome to another deep dive. This time we're going way deep into how we learn to perceive the world around us.
Perceptual learning, yeah, it's a fascinating area.
Absolutely. And we're going to explore just how philosophically significant this idea really is.
For sure. So we'll be pulling from a number of different sources. The Stanford Encyclopedia of Philosophy has a great entry on perceptual learning.
It does. And we're also tapping into some of the latest research from psychology and neuroscience.
Right, to give us a well-rounded picture of what's going on.
Exactly. We'll be looking at some of the key definitions and distinctions, really pinning down what perceptual learning is.
And we'll explore its different forms, like how it can involve sharpening our ability to notice subtle differences or becoming more attuned to certain cues in the environment.
And then, of course, we'll dive into the juicy philosophical stuff. How perceptual learning connects to debates about the nature of perception itself.
Yeah. How it might challenge our assumptions about the role of experience and learning in shaping what we perceive.
Exactly. So if you're ready to have your philosophical foundation shaken a bit, buckle up.
It's going to be a wild ride.
Okay, so let's start with the basics. What exactly is perceptual learning?
Well, the classic definition comes from Eleanor Gibson all the way back in 1963.
Okay, 1963.
She said it's a long-lasting change in perception that results from practice or experience.
Okay, that sounds pretty straightforward. But as with most things in philosophy, I suspect there's more to it than meets the eye.
You bet. There are nuances and subtleties that we need to unpack if we really want to grasp its philosophical significance.
Right. Like that word, long-lasting.
Yeah.
What makes perceptual learning different from those short-term changes in perception that we experience all the time?
Well, think about the waterfall illusion. You stare at a waterfall for a while, and then when you look at something stationary, it appears to move upwards.
Yeah. I've experienced that before.
Right. Or how about when you come inside from a blizzard and everything seems super dim for a few minutes?
Mm-hmm. Okay, I see.
Those are examples of sensory adaptation.
Yeah.
There are definitely changes in perception caused by recent sensory input, but they're temporary. They fade away quickly.
So they don't count as perceptual learning?
Exactly. Perceptual learning is about those more enduring shifts in how we perceive the world.
Okay, so we've got the long-lasting part down. But what about that perceptual aspect? What exactly are we talking about when we say a change in perception?
That's a key question, especially when we're thinking about the philosophical implications. It's not just about changes in our preferences or opinions,
Right, like if I used to love a certain band, but now I can't stand them, that's not perceptual learning, is it?
Nope, that's just a change in taste.
Okay.
Similarly, if you come to believe that a painting is a forgery, that's a change in your belief, not in how you visually experience the painting itself.
Right. I guess the perceptual part really gets at those fundamental changes in how our senses process information.
Exactly. But pinning down exactly what constitutes a perceptual change is actually a point of debate among researchers.
Oh, really? How so?
Well, some folks, like Goldstone, focus on improvements in our ability to perform perceptual tasks. Things like becoming better at distinguishing between similar shades of color or recognizing faces.
Okay. So it's about getting better at those basic perceptual abilities.
Right. But others, like Connolly and Prettyman, emphasize changes in the phenomenology of perception.
Phenomenology.
Yeah, that's just a fancy way of talking about the subjective, what it's likeness of our experiences.
Okay, so it's not just about being able to do something better, but about how the experience itself feels different.
Exactly. And then there's Chudnoff, who argues that perceptual learning can involve acquiring new perceptual facts.
Interesting. Like what?
Well, like learning to identify the specific visual cues that distinguish a robin from a sparrow.
Ah, I see.
You're not just getting better at distinguishing them, you're learning new facts about what makes them perceptually distinct.
Okay, that makes sense.
And then there's Jenkin, who offers a more expansive definition. He suggests that perceptual learning can involve changes in the content of perception, what we perceive, the format of perception, how it's represented, or even how perception guides our actions.
Wow, so there are a lot of different ways to think about what a perceptual change actually entails.
Definitely. It's a rich area of inquiry.
It sounds like it. And I imagine this debate about the nature of perceptual change has some interesting implications for how we understand perception itself.
Absolutely. It really gets at the heart of the age-old debate about the role of experience versus innate factors in shaping our perceptual abilities.
Right. Are we born with certain perceptual capacities, or do we learn them through experience?
Exactly. And perceptual learning provides a really compelling case for the power of experience in shaping how we perceive the world.
So even as adults, our perceptual systems are still malleable and capable of change.
Precisely. You know, for a long time, the prevailing view was that improvements in our perceptual abilities were mostly due to cognitive refinements. Like, we were just getting better at interpreting the sensory information that our brains were receiving.
So it was all about those higher-level cognitive processes.
Right. But research in neuroscience, particularly in the 1990s, started to challenge that view.
Interesting. What did they find?
Well, they found compelling evidence for plasticity in adult primary sensory cortices.
Plasticity.
Yeah, that just means that those early stages of sensory processing in the brain can actually change in response to experience.
Wow. So it's not just that we're getting better at thinking about what we see or hear. Our brains are actually changing at a fundamental level.
Exactly. And researchers like Feily, Garrity, and Cass, Gilbert, Goldstone, and Sagi, they've all contributed significantly to this understanding.
So our brains aren't just passively receiving information. They're actively adapting and changing based on what we experience.
Precisely. Which brings us to that last part of Gibson's definition.
Right. That perceptual learning results from practice or experience.
Exactly. And this distinguishes perceptual learning from changes in perception that are due to things like surgery or brain lesions.
Okay, so laser eye surgery might improve my vision, but it's not considered perceptual learning because it's not a result of a learning process.
Exactly. Same thing with perceptual deficits that result from brain damage. Those aren't considered perceptual learning either.
Right. They're the result of something going wrong, not of practice or experience.
Precisely. But the thing is, practice or experience can take many forms when it comes to perceptual learning.
Okay, like what?
Well, it can be deliberate and focused, like the training that radiologists undergo to get better at spotting subtle abnormalities in medical images.
Right, they're specifically practicing and honing those perceptual skills.
Exactly. Krasna and colleagues did some fascinating work on this.
Okay.
But perceptual learning can also happen through mere exposure to certain stimuli.
So even without consciously trying to learn something, we can still change how we perceive the world just through repeated exposure.
Absolutely. And this is where things get really interesting and potentially a bit concerning when we start thinking about biases.
Oh, yeah. How so?
Well, Connolly and Jenkin talk about how repeated exposure to societal stereotypes can actually lead to the development of perceptual biases.
I can see how that could happen.
Yeah, there's some disturbing research on this. Eberhard and colleagues, for example, showed that people can develop a visual bias that associates black faces with crime-related cues.
Wow, that's troubling.
It is. And Payne's work on weapon bias also shows how our perceptions of race can be unconsciously influenced by societal stereotypes.
So even something as fundamental as how we perceive other people can be shaped by these implicit biases that we pick up through experience.
Unfortunately, yes. And this raises some important ethical considerations about the unintended consequences of perceptual learning.
Absolutely. Our perceptions aren't always neutral or objective. They can be influenced by all sorts of factors, often without us even realizing it.
Exactly. And this is something that Goldstone points out as well. He argues that perceptual learning improves an organism's ability to respond to its environment.
Okay, so learning in general should help us interact with the world more effectively.
Right. And Goldstone's view on this can be interpreted in a couple of ways. One is that every instance of perceptual learning directly leads to an improvement in the organism's ability to respond. You know, like a more adaptive response.
Right.
But the other interpretation is that perceptual learning represents a general capacity, like a fundamental ability of organisms to become more attuned to their surroundings through experience.
I see. So it's not necessarily about each individual instance of learning leading to a perfect outcome. It's more about the overall ability to adapt and change.
Exactly. And this raises some really fascinating questions about the evolutionary basis of this capacity. Why are we so good at learning to perceive the world in this way?
Yeah, that is a good question. Okay, so we've laid a pretty solid foundation for understanding what perceptual learning is. But now let's get into the tricky business of distinguishing it from other things that might seem similar but are actually quite different.
Right. It's all about those subtle distinctions.
Exactly. And the first one I want to tackle is perceptual development. As we grow from infants to adults, our perceptual abilities obviously change dramatically. But how do we tease apart what's learned from what's simply a matter of maturation?
This is a classic question in developmental psychology, and it's one that takes us right back to that age-old debate about nature versus nurture, like what Markey talks about.
Is it our genes or our environment that shapes who we are?
Right. And when it comes to perception, there's evidence to suggest that it's not all just learning.
Oh, really?
Yeah. Kilm and Garrigan, for instance, argue against the view that all perceptual development is just a fancy form of learning.
Interesting. What's their argument?
Well, they point to studies showing that even very young infants possess certain perceptual abilities.
Okay, like what?
Well, things like the perception of objects and faces, motion, three-dimensional space, even the coordination between different senses.
Those seem like pretty fundamental perceptual capacities.
They do. And it suggests that those abilities are either present from birth or develop very early in life, often without any specific training.
Right. It's not like babies are going to school to learn how to see in 3D.
Exactly. So if not all perceptual development is learning, then what's driving those early perceptual changes?
That's a good question. What's the alternative?
Well, that's where the idea of maturation comes in.
Maturation.
Yeah, it refers to those perceptual abilities that emerge or become refined simply due to the natural unfolding of our biological systems.
So it's our genes, our genetic blueprint guiding that development.
Exactly. And while environmental input is still important for normal development, the initial emergence of those capacities is often attributed to these innate mechanisms.
Okay, so how do we distinguish between perceptual learning and maturation then?
It's all about the primary driver of the change.
Okay, so if it's mainly driven by experience, it's perceptual learning.
Right. And if it's primarily driven by our genetic programming, it's maturation.
Okay, that makes sense. But I imagine there are cases where it's not so clear-cut.
Oh, absolutely. One way to initially think about it might be that species-typical abilities, like face perception, are more likely to be driven by maturation.
Okay.
Whereas more specialized skills, like a birdwatcher's ability to identify different species of birds based on subtle visual cues, are probably learned.
Right. But as you said, it's not always so simple.
Nope. And as Goldstone and Faley point out, the real key is to figure out what's playing the primary role in driving the change. Is it our genes or our environment?
Right. So it's a matter of teasing apart those influences. Okay, another area that might get confused with perceptual learning is perception-based skills.
Yeah, like playing a musical instrument or playing a sport.
Exactly. We talked about that expert soccer player who's learned to focus on their opponent's hips.
Right. That shift in attention seems like a clear example of perceptual learning. But the overall skill of playing soccer obviously involves much more than that.
Absolutely. So why is perceptual learning not considered the same as a skill?
Well, Stanley and Krakauer argue that skills typically involve explicit instruction or observation, at least in their initial stages.
Okay.
Whereas perceptual learning can occur implicitly, simply through exposure and practice without any deliberate guidance.
Right. I guess it's like learning to ride a bike. You're not consciously thinking about all the physics involved. You're just doing it.
Exactly. And Goldstone brings up this really interesting study by Schifrin and Schneider, where they showed that people can develop an automatic attentional bias towards previously relevant letters, even when they're trying to ignore them.
That's fascinating. So our attention can be shaped by our past experiences without us even realizing it.
Exactly. And this kind of automaticity is often a hallmark of perceptual learning. It can operate below the level of conscious control that we usually associate with learned skills.
Okay, so the key difference is that skills often involve a more deliberate and conscious application of learned abilities.
Right. Whereas perceptual learning can lead to these automatic shifts in how we perceive the world.
Interesting. Okay, now let's move on to a topic that's always a bit mind-bending. Cognitive permeation.
Ah, yes. The idea that our thoughts, beliefs, and desires can influence what we perceive.
Exactly. How does perceptual learning fit into this debate?
Well, the long-lasting aspect of perceptual learning helps to distinguish it from those fleeting instances where our current beliefs or desires might seem to color our perception.
Like in Siegel's example of Jack and Jill.
Right. if Jack thinks Jill is angry with him, he might interpret her facial expressions in a way that confirms that belief, even if she's not actually angry.
Okay, but that's just a temporary, in-the-moment kind of influence.
Exactly, not the kind of long-term change we're talking about with perceptual learning.
Right. But Fodor's distinction between synchronic and diachronic cognitive permeation is really important here.
It is. While synchronic permeation refers to that immediate top-down influence of cognition on perception, which is highly debated, perceptual learning, occurring over time, offers a potential mechanism for cognitive factors to indirectly influence perception.
So even if our immediate perceptions aren't being directly altered by our thoughts, our long-term learning could be shaping what we perceive.
Exactly. And that learning is often guided by our goals and knowledge.
Right. We learn to pay attention to certain things because they're relevant to our goals.
Precisely. And Jenkins' example of chess players is a great illustration of this.
Oh, yeah. How so?
Well, expert chess players, through their extensive visual experience and their deep understanding of the game, learn to perceive patterns of pieces as unified wholes.
Right.
They're not just seeing individual pieces, they're seeing strategic configurations.
Right. Their knowledge and their goals are shaping how they visually organize the board.
Exactly. Which suggests that over time, our perceptions can become responsive to reasons.
That's a really interesting idea.
It is, and it suggests that perception might be more intimately connected to cognition than we traditionally thought.
Okay, but I thought you said earlier that perceptual learning was data-driven, not top-down.
Right, and it is. Raftopoulos emphasizes this point. But the thing is, diachronic permeation adds a layer of complexity.
How so?
Well, it suggests that while perceptual learning might start out as a bottom-up process, driven by sensory input, our knowledge and goals can shape that learning process over time.
Okay, I see. So it's not just one or the other. It's an interplay between bottom-up and top-down influences.
Exactly. And this complicates things for those philosophers who want to completely rule out any role for cognition in shaping perception.
Right, like Politian and others.
Exactly. And it's something that philosophers like Siegel and Cecchi have been grappling with as well.
So the relationship between perceptual learning and cognitive permeation is a bit of a tangled web.
It is, and it's one that continues to spark debate.
Okay, now I want to shift gears a bit and talk about machine learning. I know it's a different beast altogether, but I'm curious if there are any useful analogies we can draw between machine learning and human perceptual learning.
Absolutely. In the realm of machine perception, there are some interesting parallels. Just like humans learn to perceive the world more effectively through experience, machine learning algorithms learn to extract meaningful information from sensory data by being exposed to huge data sets.
Oh?
And the distinction between supervised and unsupervised learning in machines mirrors the distinction between guided and unguided perceptual learning in humans.
Okay, so in supervised learning, the machine is given labeled examples to learn from.
Right, just like a child might be taught the names of different objects.
And in unsupervised learning, the machine has to figure things out on its own, without explicit labels.
Exactly, like a baby learning to distinguish between different faces without being told who's who.
Okay, that makes sense. But I've also heard a lot about biases in machine learning. How does that connect to perceptual learning?
Well, just like in human perceptual learning, the data that a machine is trained on can introduce biases into its perception.
So if a machine learning algorithm is trained on a data set that's biased against a certain group of people, for example, it might learn to perceive those people in a biased way.
Exactly. And this is a huge concern in the field of artificial intelligence.
Absolutely. It shows how both artificial and biological perceptual learning are shaped by the information they're exposed to.
Right. And it highlights the importance of being aware of those potential biases.
Okay, so we've covered a lot of ground here. We've talked about what perceptual learning is, how it differs from other things, and even how it relates to machine learning. But now I want to get to the heart of the matter. Why is all of this so philosophically significant?
Well, for starters, perceptual learning really underscores the active and constructive nature of perception.
Right.
It's not just about passively receiving information from the world.
Right. It's about our brains actively shaping that information based on our experiences.
Exactly. Like that wine expert with their refined palate. It's not just a matter of innate ability. It's years of tasting and discriminating that have shaped their perceptual system.
So our perceptual experience isn't just a mirror of the world. It's a product of the interaction between our brains and the environment.
Precisely. And this ties into another important point, which is that perceptual learning can have epistemological consequences.
Epistemological.
Well, yeah, it can affect how we acquire knowledge about the world.
Okay.
Siegel argues that perceptual learning can either enhance or hinder the reliability and informativeness of our perceptions.
So it can either make our perceptions more accurate or more biased.
Right. And this has implications for how we think about justification, evidence, and the nature of knowledge itself.
That's a lot to unpack.
It is, but I think it's worth the effort.
Okay, so let's dive into some specific philosophical debates where perceptual learning plays a key role. First up, the contents of perception. How does perceptual learning influence what we actually perceive?
That's a big one, and there's a lot of debate about it. But one of the main claims is that through perceptual learning, we can come to represent new properties in our perceptual experience.
Okay, like what?
Well, Siegel's famous pine tree example illustrates this. After lots of experience distinguishing pine trees from other types of trees, you might start to literally see something as being a pine tree.
So it's not just about recognizing it as a pine tree. It's the property of being a pine tree becoming a part of your perceptual experience.
Exactly. And this aligns with Reid's notion of acquired perception, which Copenhaver interprets as the ability to learn to perceive properties like being cider or being an apple.
Okay. So our perceptual systems are actually capable of representing these high-level properties.
That's the argument. And it's not just limited to these kind of abstract properties either.
Oh, really?
Nope. Vedanta Deshika gives this example of a jeweler who learns to perceive subtle color variations in gemstones that would be invisible to an untrained eye.
Wow. So even our perception of basic sensory qualities can be shaped by experience.
Precisely. And Reid's example of a farmer who can visually estimate the amount of corn in a heap also points to this idea that experience can enrich the informational content of our perception.
Okay, so we might literally be seeing more than we used to. But does everyone agree with this view?
Not necessarily. Siewert, for example, offers a more nuanced perspective. He suggests that while perceptual learning definitely changes our perceptual experience, the phenomenology, it might not always affect the fundamental content of what we perceive.
That's an interesting distinction.
It is, and he gives some compelling examples to illustrate it, like the difference between simply seeing something and recognizing it as a sunflower,
Okay.
or how familiar faces seem to pop out at us in a crowd.
Right. I guess those are both changes in how we experience things, but not necessarily in what we're actually perceiving.
Exactly. And language learning provides some even more intriguing examples.
Oh, yeah. How so?
Well, Peacock talks about how Cyrillic script might look different to someone who can read it compared to someone who can't.
That makes sense. I guess once you learn the meaning of those symbols, they take on a different perceptual quality.
Right. And there's a whole debate about whether the sounds of a language actually change after we learn to understand it.
Wow, really?
Yeah. Some philosophers like Bloch, Strawson, Tye, Siegel, Prince, and Bain all argue that the sounds themselves take on a different perceptual quality.
So it's not just that we're understanding the words, we're actually hearing them differently.
Exactly, but there's disagreement about what's going on here.
Okay, so what are the different views?
Well, Callahan argues that learning a language involves learning to hear new phonological features.
Okay.
Like we're literally tuning our ears to pick up on subtle distinctions in sound that we were previously deaf to.
Interesting.
But Brogard goes even further.
How so?
Well, she argues that the meanings of words can actually become integrated into our auditory perception.
So we're not just hearing sounds and then interpreting them. The meaning is somehow directly present in our auditory experience.
That's the claim. And it's a pretty radical one.
It is. So perceptual learning is right at the center of this debate about what our perceptions actually present to us.
Absolutely. And it highlights how our experience can fundamentally shape what we see, hear, and even think.
Okay, now let's circle back to cognitive permeation. We touched on it earlier, but I want to explore how perceptual learning is used specifically in the context of that debate.
One of the main ways it comes up is as a way to explain away cases of cognitive permeation, to offer alternative non-cognitive explanations for phenomena that might initially seem like top-down influence.
Okay, so it's like a defense mechanism against cognitive permeation.
In a way, yes. For example, Conley suggests that the ability to see a pine tree as a pine tree, which Siegel uses as an example of cognitive permeation, could actually be explained by attentional weighting.
Right. We learn to pay attention to those specific visual features that distinguish pine trees from other trees.
Exactly. And Arstilla proposes that unitization and differentiation, those other forms of perceptual learning we talked about, might also account for some of these cases.
So the argument is that these changes in perception are more likely the result of our perceptual systems adapting to the patterns in our sensory input, rather than our thoughts directly influencing what we see or hear.
Precisely. And Raftopoulos really emphasizes this point that perceptual learning is generally data-driven, not top-down.
Okay.
He's saying that it's about responding to sensory information, not being directly shaped by our beliefs or desires.
Right. And this makes perceptual learning a very useful tool for those philosophers who are skeptical of cognitive permeation.
Exactly. Like Polition, Brogard, Gatzia, Stokes, and Deroy. They all appeal to perceptual learning as a way to explain away some of these seemingly puzzling cases.
Okay, so perceptual learning is on the side of the anti-permeationists.
Well, it's not quite that simple.
Oh, right, diachronic permeation.
Exactly. As we talked about earlier, the idea of diachronic permeation suggests that while perceptual learning might start out as a bottom-up process, our knowledge and goals can shape that learning over time.
Right, so it's not just one or the other. It's an interplay between bottom-up and top-down influences.
Exactly. And this complicates the picture for those who want to draw a hard line between perception and cognition.
Okay, I see. So perceptual learning can actually be used to argue for a kind of cognitive permeation.
Yeah.
Just not the immediate synchronic kind.
Exactly. And philosophers like Siegel, Cecchi, Stokes, and Bergson have all explored this idea.
So it's a bit of a double-edged sword.
It is. It can be used to both defend against and support claims of cognitive permeation.
Okay, now I want to bring in another big philosophical debate. The theory-ladenness of observation.
Ah, yes. A classic in the philosophy of science.
Exactly. And I'm curious how perceptual learning fits into this debate.
Well, the debate about theory-ladenness is all about whether our scientific theories influence what we actually observe.
Right. Do our preconceived notions color our perceptions?
Exactly. And Raftopoulos and Zaimbekis argue that theories can operate tacitly, shaping our perceptual sensitivities in ways we might not even be consciously aware of.
Okay.
They give this example of a scientist who, through years of training and experience in their field, develops a refined perceptual sensitivity to certain phenomena.
Okay. Like a biologist who can spot subtle differences in cell structures that a layperson would completely miss.
Exactly. And Raftopoulos and Zaimbekis argue that this perceptual learning, which is driven by the scientist's theoretical framework and research goals, can lead them to literally see things differently within their domain of expertise.
So they're not just interpreting the data differently. Their perception itself has been shaped by their theoretical commitments.
Precisely. And this suggests that perceptual learning can make observation theory laden.
Okay.
It can influence the very information that reaches our conscious awareness.
But doesn't that raise concerns about the objectivity of scientific observation?
It does, but Stokes argues that the collaborative and intersubjective nature of scientific practice can mitigate those concerns.
Okay.
He's saying that even if individual perceptions are influenced by theoretical commitments, the scientific community as a whole can still achieve a robust form of objectivity through shared standards and rigorous testing.
So it's about the community correcting for individual biases.
Exactly. And perceptual learning plays a fascinating role in all of this.
It does. It shows how our scientific training can literally shape how we see the world. Okay, now let's turn our attention to another big idea in cognitive science. Modularity.
Modularity.
Yeah, the idea that our minds are composed of these relatively independent modules, each with its own specific function.
Right, like Fodor's modularity thesis.
Exactly, and I'm wondering how perceptual learning fits into this framework.
Well, on the surface, it seems like perceptual learning might pose a challenge to strict modularity. Well, the fact that experience and training can lead to significant changes in our perceptual systems suggests a degree of plasticity and interaction that might seem at odds with the idea of encapsulated modules.
Right. If those modules are supposed to be self-contained and independent, how can they be so influenced by experience?
Exactly. But Fodor himself acknowledged the possibility of diachronic permeation.
Right, about that again.
He was saying that our experience and training can, over time, affect the accessibility of background information to these encapsulated modules.
Okay. So he's allowing for some influence of learning on perception, but within certain limits.
Exactly. And he used the example of language learning to illustrate this point.
Okay.
He suggested that our experience with language can influence how we process auditory input.
but he probably didn't think that this kind of influence was very widespread.
Right. Fodor held a pretty conservative view about the scope of diachronic permeation.
Okay.
But other philosophers, like Churchland, have argued for a much broader role for experience in shaping perception.
Oh,
Yeah. Churchland gives this example of how knowledge of music theory can fundamentally alter one's perception of music.
that's interesting. So someone with musical training might literally hear the music differently than someone without that training.
That's the argument. And it suggests that our knowledge can actually change how our senses process information.
Okay, but how did Fodor respond to this kind of challenge?
Well, he questioned whether these cases really represented changes in perception itself or just differences in beliefs or interpretations.
Okay.
He also suggested that repeated exposure, rather than theoretical knowledge, might be the primary driver of these changes.
I see. So he's trying to maintain a distinction between perception and cognition.
Exactly. But Stokes, drawing on evidence from perceptual expertise, argues for a more malleable view of perception.
Malleable.
Yeah. He's suggesting that our thinking can actually affect and improve our perceptual abilities.
Okay.
And this poses a more direct challenge to Fodor's modularity thesis.
So perceptual learning is right at the center of this debate about the architecture of the mind.
Absolutely. It's a key piece of evidence in the ongoing discussion about how our minds are organized and how they interact with the world.
Okay, now let's shift gears again and talk about epistemology, the study of knowledge. How does perceptual learning impact our understanding of how we acquire knowledge?
This is where things get really interesting. Perceptual learning, especially the development of perceptual expertise, has some profound implications for epistemology.
Okay.
In fields like wine tasting or bird watching, experts develop these remarkably refined perceptual abilities.
Right. They can see and hear things that a novice would completely miss.
Exactly. And there are two main philosophical views about what's going on here. One is that experts acquire new perceptual facts.
So they're literally perceiving more information than a novice.
Precisely. Chudnoff is a big proponent of this view.
Okay.
But the other view is that perceptual expertise is primarily a form of know-how.
So it's more about having a refined set of perceptual skills and abilities.
Exactly. And Burgard and Getz, here are some.